This is a deep architecture walkthrough of OpenClaw using the official repository and docs current as of March 11, 2026. I'm not going to do a wizard-driven setup or a feature tour marketing pass. The question I want to answer is simpler and more useful for engineers. What kind of system is OpenClaw really building? The short answer is not just chatbot plus integrations. It is a personal assistant control plane with a local gateway, a structured agent runtime, paired device nodes, extension seams, and explicit trust boundary choices. OpenClaw's own framing is useful here. The docs and README keep saying, the gateway is the control plane, not the whole product that matters, because it tells you how to read the rest of the repo. The system is trying to give one assistant many ingress and execution surfaces, messaging channels, CLI, web chat, companion apps, and paired devices. So when you look at the architecture, do not picture a bot living inside one channel adapter. Picture a central control plane coordinating many ways to reach the same assistant. Before reading any single subsystem, the monorepo layout tells the story. OpenClaw is not one node script that calls a model and forwards messages. It has companion applications, a UI package, a large core runtime under source, extension packs, and bundled skills. The NPM manifest also exposes many plugin SDK entry points. It is a strong clue that the team wants connectors and optional capabilities to live behind more formal boundaries over time. The architecture ambition is broader than channel automation. It is a runtime platform for a personal assistant product. This is the core diagram. OpenClaw puts one long-lived gateway in the middle of the system. It owns channel connections, the typed WebSocket control plane, the canvas host, and the HTTP surfaces, clients, web chat, and paired nodes all meet here. That is why I keep calling the gateway the system spine. The architecture is centralized on purpose. The wire protocol is another sign that this is infrastructure, not just a bot wrapper. The docs specify a mandatory connect handshake, structured request and response envelopes, server push events, auth rules, idempotency for side-effecting calls, and a distinct node role that gives OpenClaw a stable control surface for the CLI apps, web chat, and devices. It also means the transport contract is explicit. Instead of every client inventing its own side channel, they converge on one protocol with typed requests, typed events, and well-defined connection lifecycle rules. OpenClaw's session model is more serious than many chat tools. The team treats session routing as part of the security and product design. By default, direct messages can collapse into one main session for continuity. But the docs also explain why that is dangerous in multi-user inboxes. If more than one person can DM the same assistant, you likely want DM scope to isolate by peer or by channel plus peer, group, and thread context already split out. This is important because context boundaries are where architecture starts turning into actual user risk. This is one of OpenClaw's strongest architectural ideas. Multi-agent routing is not just different prompts. The docs define an agent as a fully scoped brain with its own workspace, state directory, auth profiles, and sessions. That means one running gateway can still isolate personal work or role-specific assistance without turning the whole runtime into one blended pile of memory and credentials. The repo and docs are very explicit that you should not reuse agent dir across agents. That causes session and auth collisions. The separation is real, not cosmetic. OpenClaw's agent runtime only makes full sense once you see the workspace contract. The docs list a set of bootstrap files like agents.md, sewell.md, 2ls.md, identity.md, and user.md, and those files are injected into the model context on the first turn of a session. The workspace is also the tool working directory, so memory, personality, operating instructions, and local files are not hidden inside a database. They are ordinary files on disk. That makes the assistant more local, more inspectable, and easier to version or back up. The official agent loop docs are worth reading. They show a disciplined runtime rather than a naive one-shot prompt. The gateway accepts the request, resolves the session, and then routes execution through a serialized session lane. That prevents tool races and keeps transcript state consistent. The embedded runtime handles model execution. and tool calls, while OpenClaw bridges those events into its own stream model. That is why the system can support accepted acknowledgements, streaming assistant deltas, tool progress, and a later wait call without everything collapsing into one monolithic RPC. This distinction matters because many agent products blur these controls together. OpenClaw explicitly does not. The sandbox decides whether tools run on the host or inside Docker. Tool policy decides whether a tool is even available. Elevated mode only changes where exec runs when you are already sandboxed, and it still has its own gates. That is a healthy design choice because it gives operators more than one place to contain risk. It also means debugging permission failures requires architectural literacy. You need to know which control actually blocked you. The node malus is unusually important. It lets OpenClaw extend onto real devices without moving the control plane off the gateway. Nodes are explicitly not mini gateways. Messages still land on the gateway. The gateway still runs the model and routes the policies, but paired nodes expose local capabilities like canvas, camera, screen recording, notifications, location, and system commands through node.invoke. And in remote setups, that means you can keep one central brain and still reach device local surfaces or execute commands on a different machine when the node host is configured for that job. Canvas is one of the most distinctive OpenClaw ideas. It gives the assistant a lightweight visual workspace without abandoning the central control plane model. The docs describe a gateway-hosted canvas and A2 UI surface, and the macOS app embeds that surface in a WebKit panel from the agent's perspective. This becomes another structured capability. It can show a page, navigate, run JavaScript, or capture a snapshot. So OpenClaw is not only about chat transports, it is also experimenting with an agent-controlled UI surface that still flows through the same gateway. OpenClaw plugins extend the gateway from inside the same process. The manifest and JSON schema let OpenClaw validate configuration before loading plugin code. After load, a plugin can add routes, tools, commands, services, and even skills. That is powerful, but it also means plugin trust is runtime trust. A plugin is not a harmless macro, it becomes part of the gateway. Skills do not change the runtime, they teach the agent how to use tools that already exist, and OpenClaw loads them with clear precedents and simple metadata gates. I like this part of the design because it is honest. OpenClaw says memory is plain markdown in the workspace, and the model only remembers what gets written to disk. That means day-to-day notes live in dated files. Curated durable facts can live in memory.md, and retrieval is handled by memory tools and memory plugins. The docs also describe a pre-compaction memory flush, where the system silently reminds the model to write durable notes before context gets compacted away. So memory is not treated as vague, latent magic. It is treated as an artifact pipeline. OpenClaw is clearly designed for remote operation, but the docs keep pushing a conservative baseline. Start loopback first, keep the gateway on one local port, use SSH tunnels or tailscale when you need to leave the box. That matters because the system exposes a lot through one runtime. Control plane, web chat, canvas host, HTTP APIs, and node connectivity. The remote model is flexible, but the architecture assumes you're deliberate about exposure. This is not a product whose safest story is bind everywhere and hope auth saves you later. This is where OpenClaw is better than a lot of agent software that waves vaguely at security. The security docs are blunt. OpenClaw assumes a personal assistant trust model with one trusted operator boundary per gateway. It is not claiming that one shared gateway is a strong hostile multi-tenant isolation boundary. That honesty is good architecture. It tells you what the system is for and what it is not for. Session isolation and pairing help a lot, but they do not magically turn a tool-enabled shared assistant into a per-user host authorization system. The architecture gets several important things right. It keeps transport separate from assistant state. It keeps memory and bootstrap context in ordinary files. It treats paired devices as explicit peripherals instead of magical extensions of the model. And it uses a real control plane protocol instead of ad hoc event plumbing between every surface. That combination is why OpenClaw feels more substantial than many personal AI projects. There's a real system model underneath the UX. The assistant can move across channels and devices without losing its architectural center. The costs follow directly from the strengths. Centralizing everything through one gateway makes the operator boundary very important. In-process plugins make extension easy, but they also mean plugin trust is runtime trust. The many channel adapters, node modes, remote patterns, and security levers create real configuration complexity. None of that is a reason to dismiss the system. It is just the honest price of supporting a personal assistant that can act through many surfaces. Good architecture does not remove trade-offs. It makes the trade-offs visible and manageable. My deployment advice is simple. Start with one gateway, one private workspace, one trusted channel, and minimal tool access. Add nodes only when you need device local actions. Add plugins after reading the manifest and code. And once the trust boundary stops being personal, split the system across separate gateways. OpenClaw makes much more sense when you treat it like a control plane, not just a bot.